Hans, the floor is yours. So I'm going to talk about, as Keith already pointed out, I'm looking a little bit to the soil. Now the reason I'm presenting this, I'm not a soil scientist, but there are a lot of policies now going towards soils, and I just had an interest to see what actually is possible, what is not possible. And the reason, this is also the reason I put the OIV logo up there, because actually one of the publications from last year I wrote was exactly for the OIV as a statement. And what qualifies me to talk maybe about carbon change and greenhouse gas emissions and climate change. Now this is where I come from, Chateau Johannesberg, or Johannesberg Riesling as a variety. That is part of the town of Geisenheim, and we had the 50th degree latitude north, which used to be the northern limit of growing grapes, and we all know today maybe it's the 57th degree latitude in Sweden. So I'll give you an outline. I give you some key facts about soils with respect to climate change, some public policy background, because there's a lot of things are going on. The challenge to project soil carbon under climate change, just like this. And soils, Keith mentioned it already, looking at soil temperature. In fact, they're warming faster than air. Looking at biodiversity and what we've changed in the past, and what we actually need to change in the future in relationship to soils. And climate change and cultivation practices, how they affect soil organic carbon. And that's a simulation, I'd say, study. So, some key facts with regard to climate change. The fact is, I'm not sure everybody knows this 4 per 1000 or 4 per 1000 initiative, which was created after the Paris Climate Summit in 2015. It was just based on the fact that soils are the key to sustainability, our most valuable resource. And soils store about 1.5 to 2.5 thousand billion tons of carbon. That's more than the atmosphere and all plants on Earth together. And if you talk about CO2 as a primary greenhouse gas, then you also have to talk about how to store CO2. And every day probably you see something in the news, technically problems storing carbon, problems how to keep or reduce carbon emissions on a global scale. Every year, so far, we lose about 43 billion tons of soil due to erosion. And I'll show you in a minute that this is going to increase. And in that topsoil, there's also a lot of carbon stored, because carbon is mainly stored in the topsoil, and that will be lost. And the Cut per Mill initiative, and that's the reason why actually I'm standing here, because Keith asked me to repeat a presentation I did last year in Bordeaux. And the Cut per Mill initiative actually originally aimed at increasing the soil carbon content by 0.4%. And the biggest question is, can that actually be achieved? Because if you would increase soil carbon content by 0.4%, we could largely balance all the carbon emissions of the planet. So that's the idea. 1% increase in organic carbon is equivalent to roughly 21 tons of seed per hectare, but it's also equivalent to about 160,000 liters of water storage capacity per hectare. And water, of course, we all know, specifically if you're in the Douro Valley, is one of the key issues in future strategies to maintain viticulture or make it sustainable. Okay, we're going to some public policy background. Why is this important to look at this? Now, the goal is to turn soils from a source of greenhouse gas emissions into a sink. Now, agriculture or the food system, there are some estimations that agriculture is contributing about 8 to 12 billion tons of CO2 equivalents, instead of being a sink for 3 billion tons of carbon. There are lots of carbon farming programs coming up. To store carbon in the soil, as I said in the previous slide, the soil is the biggest container, if you want, larger than the atmosphere for carbon. There's the Australian Emission Reduction Fund, there's the United States Healthy Soils Program, the European Community just issued, previous to Christmas 2021, the European Union Soil Strategy for 2030, with the goal to sequester, which means to store 310 million tons of CO2 per year in agriculture, forest and land use changes. That's the goal by the European Union. In the communication of the European Commission to the European Parliament and the Council, it was stated that since 2013, removal of carbon CO2 equivalents by natural ecosystems and agriculture in Europe has been decreasing by 12 million tons per year, which means, so this decrease has to be first compensated before you can actually achieve that goal for 310 million carbon equivalents per year. Now, just to give you an idea what is going on right now. Now, the World Resource Institute, not very many people probably have heard of this. It's located in Washington, is leading a process under the Greenhouse Gas Protocol to figure out how carbon accounting in land use will work. And the Science-Based Targets Initiative, which is part of the United Nations, the World Wildlife Fund, and the so-called Carbon Disclosure Project, is also working on which practices in carbon sequestration will be encouraged that companies can adopt. This is called the so-called FLAG initiative, and FLAG stands for Forest Land Agriculture Guidance. And it was recently published just end of September last year, and that will be rolled out to agriculture on a global scale. Now, companies paying attention to this work are big supermarket chains and any large wine company with a significant greenhouse gas or land footprint. Within, they must try to reduce greenhouse gas and enhance sequestration. That's the so-called Scope 3 of greenhouse gas targets. And the idea, again, the idea for policy is that companies will be forced to take action on sequestration, encourage soil health and improve biodiversities. And the other idea is to attract investors. Now, this will encourage the so-called insetting. Insetting means investing in the reduction of your own greenhouse gas footprint instead of the second issue, which we're doing right now, which is offsetting, which is when one buys CO2 credits which are not connected to your own supply chain. In some time, guidance and regulation will hugely encourage insetting over offsetting. And the reason for this, in fact, is that offsetting market is currently absolutely exploding because there is a limited supply of really credible carbon credits, and these will be or are bought already by big industrial companies, airlines, and so on, and the price is extremely high. So this will mean that in some time, maybe months, maybe years, for instance, in the wine industry, wine retailers and distributors who have a significant greenhouse gas footprint from sourcing wine will start to look at how and where insetting money will be best spent in sequestering greenhouse gas emissions. And that could mean that investment into vineyards, which can demonstrate a greenhouse gas baseline and carbon storage value, and how they are monitoring carbon stocks in soils, may actually be a go for investors. This is the public policy behind this. So, how can that be achieved if it really be a goal to increase 0.4% of carbon? Now, this is a study which was initiated by, also by the European Union. Soils, how much actually can be actually stored, how much carbon. And here you have the different scenarios, these scenarios for the IPCC report. I just put on the right side what that means. RCP 2.6 is a 1 degree centigrade increase by the end of the century, which is a very moderate, not achievable actually anymore. And the RCP 8.5 is a 4 degree increase in centigrade. So this study actually showed, if you could look at a kind of a moderate scenario, that probably the Scandinavian countries might be able to store more carbon per hectare, up to 50 tons. But if you look at the core in this model, the core of France, Germany, Spain, Portugal is not quite in there. But there are lots of question marks. Is that actually achievable? What the public policy requires? So England might be a future thing. So actually, the question is, can we achieve it? We have not looked very intensively on this, but we should. This is an analysis of 991 agricultural sites in Germany, croplands, not viticulture. And what these lines show, that's the current organic carbon input, which would mean even at the current organic input annually, we cannot keep the soil organic carbon content at a stage where it is right now. Now remember, we want to increase it above the stage where it is right now. If we use as a climate scenario, we see that it even is more complicated because it's faster decreasing because of warming. Or if you increase the severity of scenarios, you can see that the decrease will be even faster. So climate change is actually running into carbon reduction, and the policy issues is trying to compensate for this and even increase it to make it the same. And what would that mean? In fact, if you would need to reach organic carbon input required to reach the 4 per thousand goals in agricultural soils, that would mean an annual increase between 221% or close to 300% of organic carbon in the soil, depending on the climate scenario, just to achieve the policy goal. Now the question, is that possible at all? And soils, again, are warming faster than air. Now we have very fortunate, we have a 102-year soil temperature series in Iceland. I think it's probably absolutely unique in the world. And as I can show you, we have it at different depths, and they measured it at 3 times a day. 100 years ago already started it. Now, if you look at the average, just the average yearly temperature in the air, how that changed, every place on the planet is changing with its temperature, and then take the average per year soil temperature at 50 centimeter depth, you can see it just kind of mimics the air temperature development. Now, of course, if for carbon storage in the soil, soil temperature is an important factor, because the warmer it is, the more carbon turnover you have, depending also on the moisture you are having. Now, I give you just an overview of what has changed in soil temperature, and we have the data down, as I said, 102 years down to 1 meter. And what you see up here, I just put up the air temperature changes according to the season. So the black dots is the average air temperature from 1961 to 1990, and the red dots is what happens over the last 22 years. So it's air temperature in winter, we have roughly seen a 1 degree increase. That's air temperature in spring, a little bit more. That's air temperature in summer, about the same scale, and a little bit less in autumn. And if you look at the soil layer where you have carbon stored, which is approximately 30 centimeters, and then look what has changed over the soil profile over the last 30 years, and you can see, irrespective of where you are in the soil profile, temperature has largely increased, more in spring and summer than in winter and autumn. It's about in the upper 30 centimeters, about 1.5 degrees centigrade, which is more than the average increase in air temperature. Now, precipitation is also a very important factor for the turnover rate for organic carbon. You need temperature and moisture to achieve this. And these are those 102 years put up as an average soil temperature here and average precipitation rate for just the summer month. This is an average for June, July, August. All the data compiled. And what you see, these are the temperature conditions during the 80s of the past century. Average, annual precipitation rate is really changing. It's probably, the variation is still the same. So this was like 40 years ago. And this is what we have today. We still have that distribution in precipitation, with the exception of some really out there. And but we've moved about, you can say, 5-6 degrees if you compare it to those times. Now, what does it all mean if you put it together? Biodiversity is one of the catchwords right now used everywhere. The European Union has a biodiversity initiative. And I just wanted to say one of the additional problems we're facing, and the Douro Valley is the largest steep slope area in the world, but we also have some steep slope. And unfortunately, what we've done for economic reasons in the 60s and 70s of the last century, we have killed our small terraces to make larger plots, and of course makes it more economic, with the consequences that the slope has increased, the water runoff erosion has also increased, water retention in soil has decreased, carbon content probably also, and this is additional playing a role in the challenge of different regions to store carbon. Now, if you look at erosion and also on climate change, what you can see here, you have a projected increase by the end of the century, additionally to the 43 billion tons we're losing already, of another 22 billion tons of soil loss, just if you use a RCP 4.5, which is a moderate climate scenario. Now, half of this, almost half of that increase is due to an accelerated hydrological cycle, which means the changes in the hydrological cycle, changing precipitation events, and so forth. That's the most of these changes which will occur. And if you calculate carbon estimated loss, this would be equivalent to about an increase of another 620 million tons of CO2 lost from those topsoils of CO2, instead of sequestering. Remember the carbon policy. We've done that also for our region, some simulations for the steep slope areas, and it's irrespectively of the model you're using. You can see that basically starting at the middle of the century, we have a lot of increase in surface runoff area. And of course that will add to this type of losses. So far I always talked about losses of carbon. I did never talk about how are we going to sequester carbon. Now, this is part of the Cut per Mill initiative, calls for identifying carbon storage potentials. So on the left we have New Zealand, on the right we have France, with a carbon storage capacity. And the yellow, here, orange, red areas are those who actually have a little carbon storage capacity. So these maps were drawn to identify places where you actually would be most effective to start sequestering carbon using more organic material or other cultivation practices. This is an example from France. The ISVV has compiled a study, the Institut Français as it was called formerly, how much carbon can be actually stored in viticultural soils. And not looking at all of the figures, they identified about 150,000 hectares where you could use a permanent cover crop. and about 410,000 hectares where you could use only a winter cover crop. And then they calculated how much CO2 equivalents, which also includes other greenhouse gases, from the atmosphere into the vineyard, so sequestering it. If there is a minus upfront, this means it will be stored in the soil. And in total for those vineyard areas, they estimated that there could be a potential of 680,000 tons of CO2 equivalent per year. What is not really disclosed in there is that there was no inclusion of what climate change is actually playing a role in that, and there is no inclusion of the changes in soil temperature. This is very recently, this was an example from California. It's called ZIP, the Soil Inventory Project. The USD Climate Smart Agricultural Grant for 5 years has just allocated $2 million soil carbon inventories, and the United States Department of Agriculture has already awarded $3.1 billion in 22 to storage actions. Now, still, we don't know, can we actually store this? Now, I used what is called the Northampton carbon model, and you need monthly average temperature, monthly precipitation rate, monthly potential evapotranspiration rate, soil clay content, and cover crop or bare soil. Anybody can use it. It's freely available. It takes you some time to work with it. It took me a 10-hour train ride from Frankfurt to Vienna to figure out how to work it, but it can be done. And what it includes, it's also the ratio of decomposable plant material to resistant plant material. And the assumption, I just took some assumption, we leave pruning wood in the vineyard, we leave, of course, organic material from the leaves which drop off, and then actually looked at whether this is working. Now, this is a vineyard I'm working with the students. We recultivated all the ancient terraces because I'm a fan of terraces. That's also why I came to Portugal, because I need to be close to terraces. So, and these are, the students, we took carbon storage data. It's not important how high they are, but I just used a simulation model to see whether it actually can mimic what is happening in that soil, and it can. So I was kind of happy that this could be extrapolated to see, well, can we actually do something? Now, what we observed in Geisenheim for the evapotranspiration, because that is an important input into the model. This is the past, and then this is the simulation of the future. This is precipitation rate in the summer, hydrological summer as it's called, over the last, say, 70 years almost. And down here we have the winter evapotranspiration rate and the winter precipitation rate. Now, the simulation was done 12 years ago. So here at that rim of the window, and the simulation was done with a so-called STAR2 model of the Potsdam Institute of Climate Change. And actually, it is quite well done for summer. It's not so well done for the winter precipitation, as we observe, with the exception of this winter, much lower precipitation. So ET is changing. Now, this is for Geisenheim. How it has been changed since about 1980, and how the 4.5 scenario would predict how it is changing. And this is reality. Now, if you put reality up, this is 218. So this is 219, this is 220, 21 was cool. This is the simulation for the much worse scenario, and this is 2022. So it's rapidly changing, and it's changing at a rate which is much worse, in fact, as what we predicted with a moderate climate change scenario, which means, aside from the fact that we have changes in temperature, we also have changes in evapotranspiration. So we simulated these changes in temperature, and this is the soil carbon. The green line here, the continuous line, you can see would be all year cover crop, you leave the prunings and the leaf drops on there. And if you just, with a permanent cover crop, so you can actually increase your soil carbon with a permanent cover crop. And this dotted line is the soil temperature effect. And this is observed, so this is going to 2021. So luckily the soil temperature effect seems not to be that detrimental. It's about 2 tons of storage capacity. However, if you only do part-time cover crop in our climate, you can see that you would not be able to maintain soil carbon. There's no way that you're going to increase soil carbon storage. And the soil temperature effect will actually accelerate that problem. Now, if you extrapolate that across the world, it would add up to lots of carbon actually lost depending on the soil conservation practices. Now, if we extrapolate it with the climate change model to the end of the 2060, with a permanent cover crop, we still would be capable of increasing soil carbon, but it's finite because, of course, the storage capacity of any soil is finite. It cannot be stored ultimate amounts of carbon. But in this case, 66 tons of carbon may be sequestered if you have a permanent cover crop. Now, with a winter cover crop, no way, this is not enough. You will actually lose over the next years. So 4 per thousand initiative, I highly doubt it that it will be achievable because you don't see the CO2 emissions of the turnover rate is still going on. And this is almost the same amount of CO2 released as you can store over the same time period. Up here would be the winter cover crop, and down here would be the cumulative soil CO2 emissions of the cover crop plus the prunings. And that you don't see, and that's not accounted for. So you can play around with a model. 40% clay is much better than if you only have 10% clay. And I highly encourage everybody to look at this model and use it on a larger scale for viticultural areas. So to end up, climate change scenarios need to be closely evaluated on a large scale of soils. One of the most important outcomes of the EU Commission report and some studies published in high-end journal, in fact, is that we are lacking the advisory system to really consult smaller growers, not in big companies, but in smaller ones. And climate change has a significant impact in different scales, okay, but which all affect soil carbon storage quality and capacity. And the development of water balance is ultimate in that. You need to include that. And preserving, restoring biodiversity, and I like all the programs also here in Portugal at different scales, is extremely important. Erosion prevention, because it has a lot to do with carbon losses. And soil health is a key component, but we really need to put a question mark on the cut per mil initiative. That is going to be extremely difficult, and we need more precise and improved models and an international effort on this to go about and be successful. This guy is actually the gatekeeper of the soil temperature data, not for 102, he's only 50, but for 30 consecutive years, student cohorts who actually sampled soil carbon. So today, 195 of them. Thank you. I know it was a little bit long story.